Good afternoon, class. I have uploaded a new practice problem. It's called the bowling ball to your Canvas account. What I would like to do this afternoon is I would like to complete the problem with you. So I'm going to read the problem, underline important information, and I'm going to work through part A through D with you. So there are 4 parts to the problem, and I want to work through each of them with you. So let's go ahead and get started. The mass of a spinning bowling ball is 5.8967 kilograms. So this is a 13-pound bowling ball. Its diameter is 21.717 centimeters, and its angular velocity is 2.2 revolutions per second. So in part A, it wants us to draw a picture. Part B, calculate the moment of inertia of the spinning bowling ball. Part C, what we're going to do is convert the units for angular velocity from revolutions per second to radians per second. And then on part D, we are going to calculate the spinning bowling ball's angular momentum. So the situation is a student places a bowling ball on the ground and they spin it while it's on the ground, okay? So let's go ahead and write down some knowns. The mass is 5.8967 kilograms. The diameter of the bowling ball, 21.717 centimeters. And let's go ahead and convert that into units of meters. So 0.21717 meters. And our angular velocity, identified by lowercase omega, is 2.2 revolutions per second. Okay? In part A, it wants us to draw a picture. So let's go ahead and draw a sphere for our bowling ball. And we have our axis of rotation. So let's go ahead and label that axis of rotation. And we can go ahead and dimension this. So the diameter, and we will need to half that, and we can get the radius. So the diameter, we're going to use this here, 0.21717 meters. Let's go ahead and get out your calculator because we need to calculate the radius of our bowling ball. It's going to be 0.1086. And we are in units of meters. So for part A, we've taken care of that. Part B wants us to calculate the moment of inertia for the bowling ball. So we're going to use the base equation, I equals 2/5 mr squared. And this is the equation for the moment of inertia for a sphere. And we can apply that to our situation, which is a bowling ball. So what I have is 2/5 times the mass, 5.8967 kilograms, multiplied by the radius squared. So we're going to use our calculated value for radius, 0.1086 meters squared. And according to the order of operations, we need to go ahead and square this first. Now remember, not only are we squaring the numerical value, we're also squaring the unit value. So we have meter times meter, so we're going to wind up with meters squared. So let's go ahead and square that value. And I'm just going to rewrite this. I've got 2/5 times 5.8967 kilograms multiplied by 0.0118 meters squared. Okay, so I'm going to go ahead and take the product of these two values and multiply it by 2/5. and I get 0.0278. And let's take a look at our units now. I have kilograms times meters squared. So we know moment of inertia, our units are kilogram meters squared. So for part B, I'm just going to write the answer here. Now in part C, it wants us to convert from units of revolutions per second to units of radians per second. So we're going to have to use some dimensional analysis here. We know that in 1 revolution, we have 2 pi radians. So what we're going to do is we're starting at 2.2 revolutions per second. And we're going to multiply by 2 pi radians for every 1 revolution. So now our units of revolutions are going to cancel. So 2.2 times 2 pi gives us 13.823. And let's take a look at our units here. We have radians per second. So radians in the numerator, in my denominator, right there. So this is going to be units of angular velocity, 13.823 radians per second. Now in part D, it wants us to calculate the angular momentum of the spinning bowling ball. So what we have here, angular momentum is identified by capital L. This is going to be the object's moment of inertia multiplied by the angular velocity of the object. So we're going to use our calculated value for moment of inertia, which we took care of that in part B. So this is going to be 0.0278 kilogram meters squared. And angular velocity, we just performed dimensional analysis, so we're going to use that calculated value. I've got 13.823 radians per second. Okay, so we're going to multiply these values together. So I get 0.3843. Okay, I have kilogram meters squared times radians per second. Now remember that we're not going to transfer our angle measure here, so our angular displacement. So I'm left with kilograms meters squared over 1 times this 1 over seconds. Now we have radians in the numerator, but we're not going to transfer our angular displacement measurement. So this is going to give me kilogram meters squared per seconds. And so our angular momentum of the spinning bowling ball, 0.3843 kilogram meters squared per second. So if you have any questions, please send me an email. And when you are finished with the practice problem, go ahead and attach that to an email, send it to me, and I will give you points for it. Have a wonderful day.